Welcome. Today is part 12 of the chapter binomial theorem for preparation of JEE Main Advanced and for different state level joint entrance examination. Today also we discuss few long type problems. First problem is problem number 57 and problem is find the simplest value of the series sigma r is equal to 0 to 10 minus 1 to the power r into 10 cr into 2 minus r. We have to find its simplest value. So actually expanding it is equal to minus 1 to the power 0, that is 1, 10 c0, 2 minus r means 0, only 2. Then when r is equal to 1, this is minus 1 to the power 1, that is negative, 10 c1, 2 minus 1, then plus 10 c2, 2 minus 2, then minus this way. Last term is when r is equal to 10, that is positive, 10 c10, 2 minus 10. Now I first take the first term of this. 2 is the first term. So taking 2 common, this is equal to 10 c0 minus 10 c1 into again 1 plus 10 c2 minus this way 10 c10. Then next one is plus nothing is there, so 0 into something is 0. This is plus 10 c1 into 1, then minus 2 into 10 c2 plus 3 into 10 c3 minus this way 10 c10 into 10 with a negative sign. So minus 10 c10 into 10. So we have to find the value of these two series. For that purpose, let us take the series 1 alternately plus minus 1 minus x to the power 10. This series is 1, 10 c0 is 1 minus 10 c1 into x plus 10 c2 x square minus then it is 10 c10 into 10 c10 into x to the power 10. Now put x is equal to 1 on both sides. X is equal to 1 on both sides. So this is 1 minus 1, that is 0 to the power 10, that is 0 is equal to 1. 1 means 10 c0 this one is 10C0 minus, putting x is equal to 1, this become 10C1, this term, then plus 10C2 into 1 square, that is 1, then minus 10C3 into 1, this way it is plus 10C10. So this term is equal to 0. So here the expression within third bracket, this is simply 0. Now to find this, for that purpose, differentiate both sides with respect to x. This is equal to minus 10, minus because of that factor, 10 into 1 minus x to the power 9 is equal to, this become 0, minus 10C1 into 1 plus 2 into 10C2 x minus 3 into 10C3 x square, and so on. Now on both sides, let us put 2 10C1. Again put x is equal to 1. So that this become minus 10 into 0 to the power 9. So it is 0. It is taking minus common, 10C1 minus 2 into 10C2 plus 3 into 10C3 minus. So this value is again 0. This value is nothing but that. This one. So our answer is 2 into this value, that is minus 2 into 0 plus this, again it is 0. So 0 plus 0 is equal to 0. So answer is 0. Next problem. $58. If fourth term of square root of x to the power 1 upon 1 plus log x, base is 10 plus 12th root of x whole to the power 6 is 200. Then find the value of x. One binomial is given, one complicated, but it is a binomial. Its fourth term is given, it is 200. Then to find x. So as per condition, fourth term of that is 6C3 into first term, that is x to the power 1 by 2 into 1 plus log x base 10. This first term 1 by 2 because of it is within square root. This to the power 3 into second term, that is x to the power 1 by 12, that to the power 3. This is given as 200. The 6C3 is simply factorial 6 by factorial 3 into factorial 3 into x to the power 3 by 2 plus 2 log x base 10 into x to the power, that means x plus 3 by 12, that is 1 by 4, that is equal to 200. Now actually it is equal to factorial 6 by factorial 3 into factorial 3, 654 into factorial 3. 1 factorial 3 will be cancelled. This is 6. So that it is equal to 20. So that 20 x to the power 3 by 2 plus 2 log x base 10 plus 1 by 4 is equal to 200. That is x to the power 3 by, their LCM is this into 2, that is 4 plus 4 log x base 10. This must be, in that case, this must be 6 plus 4 is there. So 1 plus log x base 10, that is equal to 20. Just 1 minute. It is 4, so it is 6, 2, 2, and this is 1 by 4, so that 1 plus log x. So we get x to the power 7 plus log x base 10 by 4 plus 4 log x base 10 is equal to 20. Now from here we have to calculate x. Taking, this is after cancelling by 20, it is 10, sorry, cancelling by 20, it is 10. So that it is 10. Now taking log on both sides, a base 10, we must have 7 plus x log x. The power will be there, log of x base 10 by 4 plus log of x base 10 power into log x base 10 is equal to log 10 base 10, which is nothing but 1. So we get this equation. Now let us take log x base 10 as a, small a, so that it becomes 7 plus a by 4 plus a into a is equal to 1. So that 7a plus a square, 7a plus a square is equal to 4 plus a, that is 6, that is a square, this one. This they together 6a minus 4 is equal to 0. So that it is equal to, by factorizing it, it is a square plus 4a plus, no, 6, so 4. Now, it is actually equal to x minus a into 4 minus 6, so 7, so 2. Oh, how to factorize it? It is actually equal to just 1 minute. One and 4. It is a square 1 minus a. That is, it is actually a minus 1 into a plus 4 is equal to 0. By factorizing it, it is that. So either a is equal to 1 or a is equal to minus 4. If a is equal to 1, then we get log x base 10 is equal to 1. So that x is equal to 10 to the power 1, that is 10. Other value is a is equal to minus 4. So in that case, log x base 10 is equal to minus 4. So x is equal to 10 to the power minus 4, 1 upon 10 to the power 4. So answer of that question is either x is equal to 10 or x is equal to 1 by 10 to the power 4. Now take the next problem. Problem number 59. And the problem is if n and r are positive integers such that n is greater than 3 and r is less than or equal to n, then the value of sigma r is equal to 0 to n minus 1 to the power r ncr n minus r plus 2 into n minus r plus 1. So given that n and r, they are two positive integers such that these two conditions, n is greater than 3, 4 or 5 or 6 or so on, and r is less than or equal to n. These are the given conditions. Then we have to find the value of that. Mind that here these two are two consecutive integers. In R are integer. This is an integer plus 2, so it is integer, this is integer, and this is just one more than that. So two consecutive integers are there. Most of the cases, we can obtain the result by differentiating twice a relation. Let us see what is the relation. We know that x minus 1 to the power n is equal to sigma minus 1 to the power r ncr x to the power n minus r, because first term is x to the power n. Putting r is equal to 0, this become 0 to n, this is n. This is 1, nc0 means 1 into x to the power n. First term is x to the power n. Second term will be negative. It is nc1 x to the power n minus 1 and so on. It is a common formula, we know it, so simply I use it. Next time, multiply both sides by x square. X square into x minus 1 to the power n is equal to sigma r is equal to 0 to n minus 1 to the power r ncr x to the power n minus r plus 2 x square. I have multiplied by x square. Now differentiate once both sides with respect to x. So left hand side become 2x into x minus 1 to the power n plus x square into n into x minus 1 to the power n minus 1. Product of two factors, so derivative is that. So that must be equal to sigma r is equal to 0 to n. Here only one term contains x, so that this is equal to n derivative of that minus r plus 2 into minus 1 to the power r into ncr into x to the power n minus r plus 1. Okay. Next, we again differentiate the both sides with respect to x. Here is two factors. Its derivative will be two terms. Another, there is two factors. Its derivative will contain two terms. So differentiating both sides with respect to x, left hand side is 2 into x minus 1 to the power n plus 2 n x x to minus 1 to the power n minus 1. So derivative of this is two terms plus derivative of that. Here again two factors are there. 2nx x minus 1 to the power n minus 1, derivative of this. Derivative of that is plus n minus 1 into x square into x to the x minus 1 to the power n minus 2. So this completes the derivative of left hand side. Right hand side is summation r is equal to 0 to n. Its derivative, it contains only one factor of x, that is this. So it is actually equal to, I write negative sign first, constant, then n minus r plus 2 into its derivative that will come here, that is n minus r plus 1 into ncr x to the power n minus r. Okay. Now put x is equal to 1 on both sides. Put x is equal to 1 on both sides. This is 0, this becomes 0, this becomes 0, this becomes 0. So left hand side is simply 0 is equal to summation minus 1 to the power r. R is equal to 0 to n, and ncr, this one, ncr, this become n minus r plus 2 into n minus r plus 1, and x is equal to 1 means it is 1. So we get this is equal to 0. I think we have to find it. Minus sigma minus 1 to the power r NCR. So its value is equal to 0. That's complete the problem. Next, problem number 60. Problem number 60 is mm, hmm, is if Sn is equal to 1 plus a plus a square up to a to the power n, and Tn is equal to 1 plus a by 2 plus 1 plus a by 2 whole square, almost same type, up to 1 plus a by 2 to the power n. So that 1 by Tn, capital T, is equal to 1 plus 1 by Tn, into 1 by Tn into n plus 1 C1 plus n plus 1 C2 S1 plus n plus 1 C3 S2 up to n plus 1 C n plus 1 Sn. So that this is equal to 2 to the power n. So given Sn is equal to that, a GP series, finite GP series, Tn also a finite GP series, then we have to find the value of this. This series is each term is product of two factors. This 1 into that S0 here, this into S1, this into S2, and this into Sn. We have to prove that this is 2 to the power n. Now we calculate Sn first, sum of GP series. It is 1 minus a to the power n plus 1 by 1 minus a. S, this is Sn. Tn, this is again a GP series. One common ratio is this. So again it is equal to 1 minus 1 plus a by 2 to the power next higher term means n plus 1 by 1 minus common ratio is equal to 1 minus 1 plus a by 2 to the power n plus 1 by here 2 minus a 1, that is 1 minus a by 2. 2 minus 1, that is 1 minus a. 1 minus a by 2, so 2 is there. So Sn is equal to that. So we get, sorry, Sn is equal to this and Tn is equal to that. Now, to find the value of this 1 by Tn into this is equal to, value is 2 to the power n. Now let us start with the expression within second bracket. That is, let us start from here. Okay, n plus 1 c1 plus n plus 1 c2 into s1. S1 is nothing but S1, put n is equal to 1 over there. 1 minus s square by 1 minus a. Then plus n plus 1 c3 s2. S2 is equal to, again put n is equal to 2 over there. So it is 1 minus a cube by 1 minus a, and so on. Last term is this n plus 1 c n plus 1 sn. Sn is this 1 minus a to the power n plus 1 by 1 minus a. To keep symmetry, let us put here, this is 1, n plus 1 c1 into 1. 1 can be written as 1 minus a by 1 minus a. By putting 1 is equal to that, we get a symmetry. Now from this, 1 upon 1 minus a can be taken common. Here, 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 everywhere is that. Now each term now contains two terms. First one is 1, everywhere is 1, and second term is minus a square, minus a cube, and so on. Take the first term first, 1. It's n plus 1 c1 into 1 plus n plus 1 c2 into 1 plus n plus 1 c3 into 1 plus n plus 1 cn plus 1 into 1. Minus n plus 1 c1 into a with negative sign. Negative sign is taken here. So n plus 1 c1 into a, here n plus 1 c2 s square up to n plus 1 c n plus 1 a to the power n plus 1. Now we have to find sum of these two, this series and that series. Clean it first. Now this series, from here, this to that, it is actually 1 plus x, 1 plus 1 to the power n plus 1. Because this is equal to 1, then n plus 1 c1 into 1, then n plus 1 c2 into 1, and so on. So this is equal to into 1. So now this one is calculated. Then consider this one. To calculate this, let us take 1 plus x to the power n plus 1. This is simply n plus 1 c1 into 1 plus n plus 1 c2 into x plus n plus 1 c2 in c3 into x square and so on. But here we have to, there is no x, a is there. Now put x is equal to a on both sides. So this become n plus 1 c1 plus n plus 1 c2a plus n plus 1 c3 square and so on. Left hand side will be 1 plus a to the power n plus 1. So this become 1 upon 1 minus a. This, from this to that, it is simply equal to 2 to the power, this means this, so 2 to the power n plus 1, 2 to the power n plus 1 minus, this is equal to n plus 1 c1, that is 1 plus a. Oh, minus 1 is there because this term is not there, so this minus 1, then minus, it is actually n plus 1 c1 into a. So it is actually equal to Tn, how much? Tn plus 1. Ore Baba. I have, unfortunately, I have cleaned it, rubbed it. Anyway, this is equal to 1 minus 1 plus a to the power n, 1 minus a to the power n plus 1 minus 1. So that this cancels. It is equal to, oh, this is not there. Oh. Space is very small for that type of calculation. So it is 1 upon 1 minus a, this, into 2 to the power n plus 1 minus plus 1 plus a to the power n plus 1. Now taking 2 to the power n plus 1 outside, 2 to the power n plus 1 by 1 minus a into 1 minus 1 plus a to the power this, I have taken this to the power outside, so by 2 to the power n plus 1. And this is nothing but, this is equal to 2 to the power n into Tn, because 1 2 should be there for Tn. It is equal to 2 to the power n by 1 minus a into 2 into 1 minus 1 plus a by 2 to the power n plus 1. This is t to the power n. This by that is t to the power n. So answer is 2 to the power n into Tn. So Tn was there. So in our question, Tn 1 by Tn into that series to prove that it is equal to 2 to the power n. So this is actually real answer is 2 to the power n. 2 to the power n into this by that is Tn. So answer is 2 to the power n. Okay, let us stop today, and I request you to please share it and subscribe my channel.